Hey everyone, this is your Unit 2 study guide key. I'm going to work through this first one and kind of explain how I do it, and the rest of them I'm just going to kind of let you watch how I did it and make sure that your steps are in good shape and your answers are correct. So just follow along, and I may have a few tips or suggestions for you as we go. So hopefully this will be a good opportunity for you to check your answers as well as your work, which is just as important. So how many inches are there in a football field? And they tell us that we're starting out with 100 yards. Go there. And the yards isn't per anything. It doesn't say yards per second or anything like that. So the bottom of this should be blank. So then you move on to your conversion factors. Yard is in the top here, so I know my next step should be to put yards here. And there's my conversion factor for that. 1 yard is 3 feet, so now those cancel, they're on top and bottom, and you can move on. Feet is up top here, so it goes on the bottom. 1 foot is 12 inches, so now we're in the unit that we wanted in the first place, and now we can solve. Multiply across the top, multiply across the bottom, and divide. This is the answer that I got. If you want to do it in significant digits, this would be it. Okay, moving right along. For this, I would leave this answer the way that it is because you're talking about living things. You can't really round up or round down living things, so those are okay to leave like that. This isn't necessarily something that you would see in chemistry, obviously. I just liked that you had to kind of pick out the conversion factors in the question, and that's why I picked it. So you can go ahead and leave this one at 42 and it would be fine. Finish up these last couple before I move on to the next section. So now we're moving on to section 2 of unit 2, which talked about accuracy, precision, and percent error. So first thing we wanted to remember to define accuracy and precision. Accuracy is when you hit the bullseye. So it's how close the measurement is to the accepted value. While precision doesn't mean that it's necessarily close to the bullseye, it just means that your measurements were all close to each other, so you were consistent. So I would just write the other measurements. We want them to be close to each other. Now, keeping these targets in mind, remember these definitions. The accepted value is the bullseye, and then precision is when it's close to other measurements. Here, you do not have any near the bullseye, so that's definitely no for accuracy, but they're close together, so it's a yes for precision. Here, we have them all on the bullseye, so that's definitely accuracy, and they're all close together at the bullseye, so yes for precision also. Here, for accuracy, we do have one hitting the bullseye, but the other ones are scattered far and wide, so this seems a lot like an accident, not real accuracy, so no. And since they're all spread apart, you have no precision either. on these, I just thought I'd give you an idea of how to look for accuracy and precision. So we kind of guided you through the process. So just keep it in mind when you look at data on your test. So the average for this was 2.70. This was 0.2. I got 0.1. And this would be 2.70 plus or minus 0.2. On this one, I got an average again of 2.70. And this, I got 2.70 plus or minus 0.2 again. So based on those answers, I'm going to let you fill this in. Which group was more precise, or was the precision the same? I think you guys can figure that out now. So now we're going to move on to percent error. I went ahead and added the equation in here for you. And I also wrote this to remind you, and I want you to make sure and look for that direction on the test so that you don't miss any unnecessary points. So for this one, I'm going to identify my accepted and my measured, and then all I have to do is fill it in. So it says, while doing a lab, a student found the density, so that's going to be your measured, student found it, while the accepted value is here. So now all I have to do is fill it in. So accepted minus measured over accepted. Remember that this is in absolute value bars, so even if you get a negative, which you would in this case, go ahead and change it to a positive. So you do this math right here first. So you would get this before you ever divide, then do your division and multiply by 100. And the answer that I got, 3 significant figures. All of these have 3. Okay, so for number 2 and number 3, I've already marked my measured and accepted. So all I have to do is fill in my equation. So it's accepted minus your measured over your accepted, which is going to be 4.18. And again, make sure that you do this subtraction first, and it's in absolute values. And you're going to come up with this over 4.18. Do your division, multiply by 100 to get that. Once again, there's my accepted, and then my measured over the accepted. And this comes out to be 3.5. So do this division first, then multiply it by 100, and make sure you pay attention to significant digits. Number 4 is a matter of opinion, and I can't tell you your opinion, so I'm letting you guys take care of this one on your own. If you have an argument to back up your answer, then you'll be just fine. Good luck on your test. I hope this was helpful.